asked in this problem to solve each quadratic equation using the quadratic formula and to verify our result by graphing. So let's take a look at this first equation. Negative x squared plus 3x plus 10 equals 0. The first thing we need to do is to identify the coefficients a, b, and c. A is the coefficient of x squared, so that's going to be negative 1. B is the coefficient of x, so that's going to be 3. And then c is the constant term, so that's going to be 10. To solve using the quadratic formula, we're going to take the values for a, b, and c and plug them into this computation here. You're going to want to be very careful with your fraction, with how you compute the pieces, with your values that are negative, etc. So it's negative b plus or minus the square root of b squared minus 4ac over 2a. Let's plug in the values that we have. B is 3, so it's negative b, which is b is 3, plus or minus the square root of, I'm going to put b in parentheses, minus 4 times a, which is negative 1, times c, which is 10. So make sure that all of that is under the square root symbol and that your fraction bar goes all the way across. 2 times a, where a is negative 1, goes on the bottom. Let's simplify each of those parts. We have negative 3 plus or minus square root 9, so 3 squared is 9. Negative times a negative is a positive. 4 times 10 is 40, divided by negative 2. So notice that my fraction bar goes all the way across. It needs to go underneath this first number as well. If we combine here, we get negative 3 plus or minus the square root of 49 divided by negative 2. Now I'm going to split that into two pieces around the plus or minus, because remember with quadratics we usually have two solutions. In fact, we always have two solutions. They're not always real number solutions, but we will always have two solutions to a quadratic equation. So I'm going to use this notation here. I'm going to do the positive first, so that's negative 3 plus the square root of 49 divided by negative 2, and then the bottom one is going to be negative 3 minus the square root of 49 over negative 2. Well, the square root of 49 is 7, so this becomes negative 3 plus 7 divided by negative 2. Again, notice the fraction bar goes all the way across. Negative 3 plus 7 is 4. Divided by negative 2 is negative 2. Looking at the second one, negative 3 minus square root of 49 is 7 divided by negative 2. So we get negative 10 divided by negative 2. That's going to give us a positive 5. So we have determined using the quadratic formula that our solutions to the original quadratic equation are x equals negative 2 or x equals 5. Let's use our calculator to verify. I'm going to go to y equals, I'm going to clear y1, and I'm going to enter negative x squared plus 3x plus 10. y2 is 0. That's the equation that we're solving. I'm going to check that I have a standard window, which I do, and then I'm going to press graph. I have a parabola that opens down, which is confirmed by the negative value of a. I'm going to use my second calc intersect to find one of my two intercepts. So here's a horizontal intercept at negative 2, 0, meaning x equals negative 2 is a confirmed solution. Let's use the second calc intersect process again to find the other solution and verify that x equals 5 is our second result. I need to use my arrows to move my cursor closer to my second crossing here. Now I'm close enough. I can press enter 3 times, and that should verify that 5, 0 is a horizontal intercept, meaning x equals 5 is a solution to the original equation. So we have solved, we have checked to verify, and our two solutions are x equals -2 or x equals 5. We're going to use the same kind of process with part B. The first thing we need to do, however, is to make sure that our quadratic is in standard form, meaning that we want to subtract 3 from both sides and set our equation equal to 0. Once we do that, we can identify the coefficients. A is the coefficient of x squared, so that's 2. B is the coefficient of x, so that's -4. And C is the constant term, so that's -3. I'm going to plug those into my quadratic formula very carefully. X equals -b, so that's -4. Notice the use of parentheses. Plus or minus the square root. I'm going to need a long square root bar. -4, that's my b value squared, minus 4 times a times c, which is -3. All of that is going to be over 2 times a, which is 2. If I begin to simplify, -4 is +4 plus or minus square root. -4 times a -4 is 16. Negative here times a negative here means I'm going to have a positive result. 4 times 2 is 8 times 3 is 24. Divided by 2 times 2 is 4. That's going to give me 4 plus or minus the square root of 40 divided by 4. Now I'm going to need to be very careful. I cannot cancel the 4's because this 4 in the bottom is a common denominator to this 4 in the top and the square root of 40. But I will be able to simplify using the following process. 4 plus or minus, I'm going to write 40 as 4 times 10. Then I'm going to write 4 times 10 with the square roots as the square root of 4 times the square root of 10. I can break up a square root that way as long as I am multiplying. You'll see why I'm doing that in just a minute. If I continue down here, I get 4 plus or minus this square root of 4 result is 2. That gives me 2 times the square root of 10 divided by 4. So I'm getting closer to being able to remove a common factor, which is my goal. Between 4, 2, and 4, I have a common factor of 2. If I remove a 2 from every term in the numerator, I get the following. 2 times 2 plus or minus the square root of 10 divided by, and I'm going to write the denominator as 2 times 2. Now I have this common factor of 2 in the numerator and denominator that can be removed, leaving me with 2 plus or minus the square root of 10 over 2. Once again, I cannot cancel these 2's for the same reason I could not cancel these 4's. I'm going to work with my two parts of my computation. I have 2 plus the square root of 10 divided by 2, and I have 2 minus the square root of 10 divided by 2. If I do those on my calculator, being very careful, you might want to consider putting parentheses around the numerator if you're going to use your calculator all at once, or compute the numerator and then divide by the denominator. In fact, let's go ahead and illustrate that using the calculator here. So my preference is to say 2 plus the square root is here, of 10, get a result. I'm going to take my arrow and move to the outside of that square root, hit enter, that gives me a result, and then divide it by 2. That gives me, and let's round to 2 decimals, that gives me 2.58. Let's do the same kind of thing with the second one. 2 minus square root of 10. Again, I'm going to see how this flashing cursor is stuck underneath the square root bar. I'm going to move it outside so I can get an accurate computation and then divide that whole thing by 2, and that gives me negative 0.58. Let's round that also to 2 places. So I get x equals 2.58 or negative 0.58. Those are my two solutions obtained from the quadratic formula. Note that these two solutions here are exact, and these last two are the form rounded to 2 decimals. Let's double check in our calculator. Going to y equals, I'm going to enter the standard form equation after clearing my y1, so that's 2x squared minus 4x minus 3. Check that I have a standard window, which I do from the previous graph. Hit graph, and I can see where I cross. I'm going to cross here and here. My horizontal intercepts will give me my solutions to my quadratic equation. I'm going to use second calc number 5. Hit enter 3 times, and that's going to give me the left one, which is indeed negative 0.58. So the left solution has been confirmed. Second calc number 5, I need to move my cursor so that I'm closer to the second intercept than the first. Hit enter 3 times, and this should confirm the 2.58. So I've confirmed my solutions. Notice that your calculator will not give you the exact solution. So if you're ever asked to find an exact solution to a quadratic equation, if it doesn't come from integer solutions, you're going to need to use this quadratic formula.